All right, here is problem 14.3.19T from the chapter 14 assignment. This shows an ANOVA table similar to the one you would get if you ran the regression in Excel. Anyway, so they're just trying to teach us the interrelationship between each of these parts. And so we can kind of go from there. Anyway, so what I did is I just sort of transferred all of this over here to an Excel spreadsheet and highlighted the fields that are the ones that are missing here. So first of all, our degrees of freedom will always add up to the total. So if the regression is 1, then our residual is just going to be the total minus the amount of the regression. And then our SS is going to do the same thing. So we'll just take 900 minus 500. And then our MS is actually just our SS divided by our degrees of freedom. And then our F is a little tougher because we have to solve a little formula here for that. And that is just going to be our sum of squares regression divided by our sum of squares residual over our degrees of freedom. And that should be all of them. There we go. So again, the MS column is just taking the SS column divided by the DF column. And then the F column is taking our SS regression divided by our SS residual over the DF, or degrees of freedom per residual. And that'll give us our F statistic there. All right, so how many ordered pairs are in the sample? So this number right here, this degrees of freedom per residual, represents n minus 2. So if we just add 2 to that, so 6 plus 2 is 8. That'll be our n, or the number of ordered pairs in the sample. All right, so to calculate our coefficient of determination, or our R squared, that is just our SS regression divided by our SS total. That's 3 decimal places, so 0.556. Now it says, using alpha of 0.05, what conclusions can be made about the population coefficient of determination? Determine the null and alternative hypotheses. So this is always going to be that our p squared, our null is that it is less than or equal to 0. Our alternative is that it is greater than 0. All right. So now it wants us to calculate the t-test statistic, or no, it's not the t-test, it's actually an f-test statistic. Even though I don't think they go into it very well in the chapter, we're using like an F distribution when we're dealing with coefficients of variation and things like that. So this this F right here is actually our F test statistic. So we just put that same number in. And then determine the p-value. We're just going to do equals F dot dist dot right-tailed. For our X, we're going to use our 7.5. For our first degree of freedom, we're going to use the DF regression, which is 1. And for our second degree of freedom, we're going to use our DF residual. And that will calculate our p-value for us. 0.034. And then finally, we're supposed to talk our way through this. So in this case, our p-value, 0.03, is less than our alpha. So if our p-value is less than our alpha, that means that the probability of getting this test statistic is less than the probability represented by our alpha, which means we're going to reject the null hypothesis that it is less than, and we're going to accept the idea that it is very likely that it is greater than 0. So we're going to say reject the null hypothesis because it appears that that's greater than 0. And that's it.